Okay. Good morning, everyone. Thanks very much for having me. I'm Hongyu. I'm also a graduate student in the systems group, as Ben is. And today I'm very excited to talk to you about a new project we are having, Cloud-Centric architecture with secure data management. So the motivation of this project was really rooted in the computing trends we are having, right? So currently we are having all kinds of applications, for example, ChatGPT, gaming applications, streaming, and etc. And they are requiring more and more compute and memory from our devices. And another trend is that Moore's law is ending. So in computer science, what Moore's law says is that every approximately 2 years, the number of transistors we can cram on a single chip has been doubling. But this trend is dying, meaning, and also on the other side, on the energy side, it says that as our devices are more advanced and faster, the amount of energy they consume was also decreasing, approximately at the same rate. But this has been put to a slow death for a couple of years. And as a result of that, we're having larger and larger device. So for example, my laptop is getting heavier and heavier, and our phones are getting bigger and bigger. This is because we can't get the same amount of performance for free anymore without burning more energy. And you might have felt that your newer versions of iPhone and other mobile phones is draining power much more quickly than prior versions, although the battery capacity is increasing over the years. And this really has resulted in a lot of e-waste. Right? We are replacing and updating our devices more frequently than we should have, and also with wasted lots of our money. And most importantly, those phones and devices are containing rare earth metals, which are non-renewable. This is quite a big issue. That's why what we wanted is to ideally move all the compute to the cloud, meaning that we want to run the big, heavy lifting applications in the cloud, or personalized AI models in the cloud, and maybe interactions between them, and so that we don't rely on our devices as much as we are now. And so ideally, the user would access the cloud via a so-called thin client, meaning that we want to minimize the reliance on the client-side device as much as possible. For example, the client could have only just a screen, and all the access or updates, screen updates, would ideally streamed from the cloud via the internet to the user device, so that a user would just click, send their interactions to the cloud, and the cloud would react, send the screen updates, just as if it's a video application. Okay, but at this point, you might be skeptical because I have said, I want secure data management, and now I'm moving everything to the cloud. Maybe it's on AWS or Huawei Cloud or any other cloud providers, and this is really hard to protect the safety and the personal data of the users. That's why what we also want to keep is we want to keep the personal data local to the user, and to have user to let user have the control, physical control, and the proximity to their data. So what we want is to add a so-called data box, and you can think of the data box as a database that keeps user data and also traces all the interactions between the user and the cloud. So it makes sure that for every single interaction from the cloud, for example, if my one application wants to access the photo, this request should be explicitly sent from the cloud to the user device, and the user should also explicitly authenticate such requests. And all the interactions and activities should be logged and audited by the data box, so that we know which application has made or which action on which of the piece of data from the user. So that in case of security breaches, we can make sure that the data provenance and everything is held accountable. And also, we are also investigating three-party contract, meaning that, for example, for the model, so we have model holder, data holder, and potentially other parties. And between any important activity has happened, we want to sign bilateral contracts between these parties so that the data is logged and we make sure that they do the right thing on the data we are expecting. So to quickly summarize, because of a computing demand, we want to move everything to the cloud, but for protecting the user data and privacy issues, we want to keep the physical control and the proximity of user data. But there are also a couple of challenges. For example, the network connectivity is obviously an issue. We are heavily relying on a strong network connectivity. Although network coverage is doubling approximately every 2 years, and it's still going strongly. But this is a critical part of our system model. And also there are sophisticated security attacks. For example, as you can see from the previous slides, there is a double error between the data box and the user. So there could be impersonation attack and so on. And also the data logging issue in the literature, we found that the amount of, the kind of traces and activities we are logging locally might not directly relate to the kind of activities happening in the cloud. So that's also one of the issues we are investigating. But yeah, that's pretty much it, the project on a high level. And if you have any questions, I'd love to answer them, and feel free to hit me up if you are interested. And thank you very much. Question?
Okay, of course, that coming back to this, that I don't believe this kind of black and white things, and one of the things what I have been already understanding in ICRC is that we are always operating in the worst possible places, which is meaning that network connectivity in Gaza today is awfully bad. And
right.
Unfortunately, we don't have the luxus, usually, except the delegation for cyberspace, which is in Luxembourg, where we are having an excellent network connectivity. So, of course, the question is that are we now trying to fix with these things what we have been teaching from the users, which is more is better? The question is that could it be combined for the other things which would be making that interesting, that what we are also trying to achieve is that less is better. When we are creating our PCs and mobile phones, we have been already saying is that don't expect Ferrari. We are just building the Toyota Land Cruiser, because this is the model what we are using also in the real life with the field operation. We are not having the fanciest car, but this white Toyota Land Cruiser is usually taking the people there and bringing them back, which is enough. And we have been saying that, okay, could you be compiling that what you are saying in the case that we would be creating a very less network connectivity needing applications. We have been promising only with the Massimo to our management that you will be getting 5 applications in our phones or perhaps in the PCs, but we are trying to optimize those that they would be eating so less bandwidth as possible, because if we are getting 1 mega in Gaza, that's a golden mine already. Hopefully you are not you might be only getting 500 kilobits, which is totally irrelevant here, but there it's already super succeeding.
Yeah.
But could we be connecting that kind of approach and seeking this kind of throttling of the internet connectivity and try to achieve the goal, so that we would be having the security, you would be able to use the cloud, and but actually you would be able to use that in very, very low connectivity and bandwidth.
Yeah, thanks a lot for the point. I think if I understood correctly, So for normal applications, for example, if you want to do like very fancy graph processing applications or some media applications, then they are typically requiring like high amount of bandwidth because of the unique application requirements. And what you are saying, if I understood correctly, is that if we can find kind of a good middle ground where we modify the client application or the design of our application in a way that we minimize the amount of bandwidth from the starting point, so that this kind of architecture is more feasible in scenarios where we have very limited or even impossible high bandwidth, if I understood correctly. And I think that's...
Even it can be cost impact, because when we are using now, for example, in ICRC, Teams for the communication, SunHealth was making for us this kind of Jitsi fork, and we were finding out that it's consuming 25% of the bandwidth what they compare to Teams, and still the quality of the picture and the sound were equal. Of course, that we were saying to our IT management that in same bandwidth what you are purchasing from the satellite with a very high price, we could be having either 4 connection or you are saving 75% of the cost with the satellite connection. Which way do you want to go? So we are not saying that Teams is a bad application. It's just that it has so fancy things in its build that it's already actually for our purposes it's too fancy. Too many things, too much browsing, huge amount of side channel connectivity and so on. We don't need those. But it would be beneficial to have a connectivity with the cloud and trying to get that in so small bandwidth as possible, because it would be also cost issue, because we would not like to pay so much money for the satellite providers. We would like to use that for the beneficiaries, and if we are able to save money with the satellite connection, it's something what we can give for the beneficiaries at the end of the day.
Yeah, I think that's a really excellent point. I think we've been thinking about like how to make this kind of architecture feasible for the nowadays applications, but I think thinking from the other side, from the like design principles from the software maybe is a more feasible way to approach this kind of problem. But I totally agree, and I think that's an excellent point. Thank you very much.
Question on the challenge, the last one, data activity logging.
Yeah, sure.
If you can elaborate on that, and then my second point of your research is about. You started describing your project because such devices, they need more and more computing capabilities and storage. You are dividing the storage is staying here, so we have to increase this space, but leaving the computer capabilities on the cloud. So how you can achieve the results of your research if we're still increasing the capability of the end point in terms of storage, because the data will stay local. So
right.
How do you work on this?
I see. Thanks a lot for the question. So there are two parts. So for the first question is, what I mean by like data activity logging for the last challenge. So what I wanted to say is that so the kind of activity we can log. So if I can go back very quickly, is the data accesses. Mm-hmm. So for example, the application wants to access your photo and if makes a formal request. But think of a scenario where this application wants to share this photo with another application directly. And this kind of activity could be missed by the local logging. And that's why we're concerning the kind of data activities we're logging can diverge from the actual activity from the cloud. And this is one of the things, one of the reasons why we are considering signing contract as to how you should use the data apart from logging your activity locally. And for the second part, if I understood correctly, the question was, so the motivation I started was that the applications are demanding more and more power, and our local devices can't keep up with the demand they are requiring, and this is not sustainable from energy point of view or from the device manufacturing point of view, and how this can be solved by just having everything in the cloud while storing the data locally still. So I think that's an excellent point. So what we want is that although we are having lots of things stored in my phone, for example, I'm having terabytes of storage on my phone, but the amount of personal data is limited. So most of them are consumed by the applications and their activity analysis data and their logs they're having. So I think ideally what we want is that we only want to keep the limited amount of personal data locally, and having all the activities and the junk those applications are providing in the cloud. And still, maybe the data box could still be large, but we hope that by limiting the data to only personal data and critical data, this could restrict the device utilization. And also for this device might not be just a very high end. Maybe it could be just a low end device and a hard drive instead of a device you need to be updating every other year.
Maybe just one follow-up question. Sorry for.
Sure. Yeah.
As personal data, what do you mean? I mean, if I'm recording a video, is it considered personal data and be stored locally? And who is defining? Is the user defining what is personal, what is not personal?
Yeah.
I mean, what's going to happen on the end user side?
Right. Right. Thanks for the question. So yeah, the question is how we define what's personal for the data. I think that the labeling of the personal, being personal or not, should be the user's responsibility. So we've looked into the literature, but this is very a controversial topic. So as you said, for example, the video we are recording or something we're doing, if that's personal to you or not. I think so. This would still leave to the end user to decide whether that's. But yeah, that's a really good question.
Thank you.
Right.
Yeah. Question on this side. So you mentioned the data box, for instance. Just wondering on that side, is that also something you'd be willing to explore a bit further? For instance, seeing how data box or any sort of data can be made anonymously public, just to increase the transparency. Let's assume, for instance, we have 300 applications as an example that people are accessing. We would like to also ensure and assure everyone that no one else other than the same person is accessing it. Is there something that you would be interested, for instance, to in some or the other form anonymize it, yet make it public, so that someone can actually view it and see that, okay, this is not something that is fishy, seems normal, seems issue, or so on?
Right.
As a standalone component, let's say, that can be plugged into any of the services or applications.
I see. So if I understood correctly, the question was if we are also looking to the implementation or the device of the data box so that it's open source, for example, like RISC-V, this open source ISA, so that everyone can pick into it to look into if it's doing something fishy. That's a really excellent point, I think. So data box is, I should have clarified, this is only a system model as to it defines what is need to be there to facilitate the production of user data. But it doesn't define what kind of devices it has to be run on and other like physical requirements. So technically it can run on anything like anything open source and secure. So it's just a system design. And also it's a practical model. We're also looking to other theoretical models with very formally defined threat models like data bank from ETH. But yeah, so that's if that answers your question. Yeah, thank you.
Okay, thank you very much.
Thank you.